This chapter will be covering 3D modeling. Our objectives is to understand the relationship between the DPC and the 3D textured mesh. Also, we must learn how to remove excess noise from the point cloud and comprehend the importance of constraining the project using the processing area. We will discover how to leverage processing shortcuts and to learn how to derive the best 3D model. In the previous chapter, we explored the dense point cloud. The DPC, in actuality, is a 3D model in the sense that it is a collection of points with coordinates in both the horizontal and vertical axes. Aside from a standalone deliverable, the DPC is considered a building block from which numerous other deliverables are built from. The 3D textured mesh, or the 3DM, is a deliverable that is generated during step 2. It is a derivative of the DPC. It is the composition of an assembly of triangles. The distance between the mesh and the points of the point cloud is optimized to be minimal, but this means that points in the mesh do not necessarily correspond to the points of the point cloud. Since the mesh is 3D, it is unfolded onto a 2D plane in order to define the resolution, or pixel size. Then the 3D position of the pixel is reprojected into the original images to obtain the color. Blending is used instead of stitching to generate the texture of the 3D textured mesh. The end result is a deliverable that resembles a traditional called 3D model. Since the 3DM is a derivative of the DPC, it is important that the DPC is classified. When satisfied with our classification, it is possible to generate the 3DM as a subset. Now, this chapter will cover advanced methods of manual classification, with the end goal being that we derive the highest quality DPC. We will then discover how to establish a boundary around our data set to remove unwanted data. All three tasks will be maximized in the final 3DM. We will begin our work with a pre-processed project, as what we did in the previous chapters. Now, the project data and the images are located in the L5 data zip folder, which I have brought out to our desktop. We will unzip this, and then we'll move the L5 data over onto our last name underscore pix4d file. This will take a few minutes to move. And when it's complete, once you open it up, take a look at the L5 data, open that file up, and then look to see that all of the images are in the O1 images file. And the folder called O2, you can see that there is a 3D model pix4d file. At this point, what I want you to do is double-click the 3D model, which is the pix4d file, and up comes our pix4d mapper. Now, as before, when it comes up, it's going to be asking for the images. You'll say OK, and then we'll go into the pix4d file, L5 data, okay, and open and select the O1 images, because that's the file that's all of our images on. We'll click that, it will upload, and when it's finished, it will bring up the map view. Notice this project was flown over a large communication tower that you see in the center. It's in the city of Waterloo, Canada. And we go up to the ray cloud. Let's click that, and you'll see the automatic tie points, which is down here, and the camera locations. And then click the box for point clouds right there. And then use the navigation tools to explore this area. So take a few minutes and explore it, go in and out, See how your cameras are rotating around it. Also notice that the angles of the photos is oblique instead of nadir or straight down. Notice that the extents of the DPC spread out far beyond the tower itself. Now, I want you to do is I want you to check the box of triangle meshes, which is right there. Now, if the triangle meshes is grayed out to where you cannot, no matter what you do, you can't click it on, it'd be grayed out, check down to the processing options and make sure that the Generate 3D Text Meshes has been checked. If it hasn't, check it, say OK, and then go to Processing, make sure that the initial processing is not checked, and then start the Step 2, not the 3, so make sure that 1 and 3 are off, make sure 2 is checked, and start. Once that goes through, then the triangle meshes will be highlighted so that you can check it on. So by checking the triangle meshes, you can observe that the quality of the 3DM, particularly where the tower is, so we can actually bring ourselves in and look at the tower, and you'll find that the tower is much more defined. Now, the question is that does it appear to be really clean? Now remember, our abstract stated that the 3DM is a derivative of DPCs. This means that the quality of the 3DM is directly dependent upon the quality of the DPC. The artifacts on the tower are what we call noise. Noise is a byproduct of every photogrammetry DPC. It's unavoidable. Now you can remove the noise, however, by using advanced classification techniques. So zoom in as close as you can, but you can see the artifacts or the noise is pretty predominant around your tower. Now we have identified that noise from the DPC is the reason our 3DM appears to be of low quality. In this task, we will remove the noise using a tool called Image Annotations. Now it's time for us to circle back to the DPC in order to perform a manual classification of noise on and or near the tower. So what we're going to do is we're going to go over and uncheck the triangle meshes and uncheck the automatic. Locate the top portion of the tower in the data view and then left click on one of the tower points in the DPC. The point will turn red indicating you have selected it. Now locate the top portion of the tower as you see in my data view. Now in this data view, left click on one of the tower points in the DPC. So if you look at one of the tower points, which is right about there, we click it and it turns red. You see a little red dot right there? That indicates you have selected it. Now view the properties of the point in the properties window over on the right, and notice that the photos appear in the image view. There's a green X in the photos. The green X in each photo corresponds to the location of the selected point from the DPC. The goal was to select a point on the antenna of the tower. Therefore, the green X should land on the antenna in these photos. But it does not do this in every photo. This misalignment is the cause of the noise points on the tower. Now, what we're going to do is use our mouse and double click on one of the photos where the X is misaligned. The selection window will display the properties of the image. Click the button that looks like a pencil. This will take a few seconds. The tool is called Image Annotations. The software will take a few seconds to segment the image. That means you can edit the pixel of only the selected image. And when we look at the selection, at the very bottom you'll see the annotate. And right beside it is a drop-down window. We bring that down. There are 3 different image annotation modes. The first one is mask. Pixels annotated using mask will not be used to generate the orthoplane. We do not cover orthoplanes in this manual or in this lessons. The next one is carve. Pixels annotated using carve will not be used to generate the DPCs. Then there's global mask. Pixels annotated using global mask will not be used to generate the DPC and or the orthomosaic. For this exercise, the carve annotation is the most appropriate. So we're going to use the carve. So we want to select that in the drop-down window. Now the next step is to perform a manual classification using the carve tool. So when we hover the mouse over the image in the selection window, you hit space bar and it comes up full. This will enable the full extent of your image. Now, of course, to exit it, you just hit the space bar again. But now notice that your mouse pointer resembles a pencil. What is happening is that chunks are larger or smaller, depends on how homogeneous the pixels are. The more homogeneous, the larger the chunks of pixels, and vice versa. The chunk size will also based on zoom scale. The closer you zoom in, the smaller the chunks get. So what you want to do is just go over, I've already done a few, but go over and then click and hold your left mouse button and then let go, and it will highlight that area. And then when you're done, you can go back and then hit apply. And then what will happen is that it will apply. And then when you look at the main window, you notice that on this black area, that means they just disappeared. Okay. So now what we've just done is we performed an image annotation. The points are now removed from the DPC. Therefore, we consider this an advanced form of manual classification. And you can reference to your manual as well. Now, if you highlighted pixels by mistake, you can unlight them by revisiting the annotation image. Hover your mouse over the highlighted chunk. Notice that your mouse symbol changes from a pencil, you see here, to an eraser. So you click and hold the eraser and let go, and it unhighlights them. The goal of this exercise is to highlight the chunks of pixels that were contributing to the noise, really on or near the communication tower. So remain in the carve mode and ensure that your image is in full screen. Now what I want you to do is to zoom into the antenna of the tower and begin to highlight all the features that are not the antenna. For an example, I want you to highlight the white building, the parking lot, the vegetation, etc. And remember, the closer you zoom in, the more precise your highlight will be. Try to get near the antenna and highlight all the pixels that surround it. Now this is a process that you must be patient with this tool. It takes a lot of time, and it takes time to get it right. So into review, you click on, and then you on the antenna, and then what you do is you go over and you find something that's not quite there. You click on that one, double click, you click the pin. Now you wait for the processing, is creating the segment. Then when it's done, hover your pen over the selection image, hit spacebar. That will bring it all the way up. Now what I want you to do is you can bring it out to get the very large areas, but everything around this, what we're going to do is we're going to select it. And you do that as we said, take the pen, go over the area, click and hold it for a second, and you can release it. And then what I want you to do is highlight everything from the buildings to the parking lot, the grass, everything that's not the building. Then when you get a large group of it, all of it highlighted except for the tower, then do a space bar, come back, hit apply. Now also pay close attention to the points on the tower antenna. Slowly, as you annotate more and more of these chunks, you will remove the noise from the antenna. Remove as much noise as time permits. So spend a half hour to an hour to extract this to derive the DPC of the communication tower. Now you may have to annotate several images before you are satisfied with the results, but continue to do this. Now in the previous chapter, we noted that the extent of the DPC spread well beyond the communication tower. Now in this task, we're going to use the processing area to constrain the extent to just the tower itself. Now, again, your image should look a lot better than this because you'll have totally eliminated the outside areas and getting rid of all this noise in and around your tower. Now, it's best to reset our view to a zoom extent. This means we view the data from the top-down perspective, and the zoom is extended far out as it exists. So we're going to hit number 7 on your keyboard, and that will extend the whole view as far out as possible. Now, without rotating the data, zoom in on your tower. Ensure the tower is in the center portion of the view. Let's get a little bit closer. Make sure this is the center view. And then click the new processing area button located under the Create toolbar, which is right up here at the top. And that's that first button, Create Processing Area. Use the left click of your mouse and digitize your processing area around the extents of the communication tower. This is a subjective task, and it's up to your judgment where the extent should go. So we'll just put the extents about in there. When you're satisfied, use the right click mouse to close the program. And notice that the ATPs or points from the DPC, which are beyond the extent of the processing area, they've all disappeared. You have now constrained the extents of the project using the processing area. The processing area is a three-dimensional, meaning it has a ceiling and a floor. Rotate the data. You can rotate this to get your view. So you can actually see that it is a three-dimensional area. In your property selection window, you can adjust the ceiling and the floor. So up in the top right in the processing area, you can actually adjust this and make the number of adjustments to your satisfaction. When done, you can click Apply to enable your adjustments. Now be careful. If you set the ceiling or floor too high or too low, you will just basically chop the top of it off. But just like any other layer, the processing area may be turned on and off by checking this box in the Layers window. So over in the Layers window, you see the processing area is highlighted. You can click that on and off. But the processing area, like I said, will remain active regardless if it's turned on or off. Now, in this part of the chapter, we will assume you have spent the necessary amount of time in performing image annotations and have established a processing area. Now, with those tasks complete, you're able to regenerate a much higher quality 3DM. To do this, what we're going to do is go up and click the Processing tab at the very top, and then select and click the Generate 3D Textured Mesh. And you want to make sure that you save it. If you don't save it, all the previous work will be lost, so be sure to click Save. Now notice that the processing bar at the very bottom of the left of the screen, this is an indicator that the software is processing this and only this subset. Now this will save you hours and hours of time instead of processing the step 3 all over again. Now once you complete this process, check the box for the layered transition triangled meshes. And observe your newly generated 3DM. So look to see how it looks. It should be constrained to the extension of your process area, and the quality should also improve. If it's not, go back and do some more image annotations until you get a satisfactory view of your antenna. Now, the purpose of this lab was to develop the highest quality 3D textured mesh. Since a 3DM is a derivative of DPC, we needed to perform an advanced manual classification technique known as image annotation. Lastly, we constrained the image to the project with the processing area. Now, it is advised that image annotation be used in combination with other manual classification tools discussed in the previous chapter to develop the best DPC possible. Consequently, the latter will yield the best 3D model. Now, in the final part of this chapter, we'll want you to save the project with a personal name. This is your deliverable to your instructor. So click on the Project tab and select Save Project As. So you go up here and Save Project As. Ensure that you're in the O2 directory. If you look up there, L5 Data O2 Project. And give the name your last name _ L5. And then click the Save button. After it saves it, navigate to your folder onto L5. Okay, projects, and then where you see the Pix4D file, the last name L5, Pix4D file. Okay, right click it and save. Let's see here, right click, send to, compress file, and there it is right there at the very bottom. And I want you to then deliver that particular file to your professor.